In this section, we will discuss about ingress replication using static method. Okay, so when the end host are communicating the first time, okay, so the VTAPs or the leaf switches, they are going to receive the bump traffic or the broadcast traffic, right? Let's say host 1 is trying to communicate with host 2, so at the very first they are going to send the ARP request, right, to find out the MAC address against the IP address. So in that case, once the leaf switch receive the bump traffic, it needs to decide where to send this particular traffic. So for that, we will use the ingress replication method. So the first one that we are going to discuss today is the static ingress replication. So once the R process is completed, now because the leaf switches or VTAPs, they are going to receive the unicast traffic. So via the R process earlier, they already know the location of the end hosts, that which host or is behind which VTAP or which leaf switch, so they can directly send the traffic to that particular leaf switch. So what are the benefits of the ingress or the static ingress replication? So it is very easy to configure. I'll show you today. And in the underlay, there is no need of multicast. The drawback is that it is not scalable. Now you can imagine that because we need to configure all the remote VTAP or leaf switches IPs manually. Okay, so let's say you have small network. Okay, so in a small network it is perfectly fine because you have small number of leaf switches, so you can do the manual configuration. But if you have a large network, then there will be scalability issues, because as soon as if your number of devices increases, then the manageability will be difficult, because you need to configure all the remote leaf switches IPs manually on each and every device. And once you remove any device from your network, then again you have the manual job. You need to delete the configuration for that particular device that you are removing from each and every device, right? So we do have these scalability issues with static ingress replication. So there are some verification command that we will check after the you can say the lab. So let's see what is there in our lab. So we'll use in our lab today spine 1, leaf 3 and leaf 5. We will try to communicate host 1 to host 5. The interface which is connected to leaf 3 and host 1, it is Ethernet 1x1, and on leaf 5 we have Ethernet 1x3. So on both leaf 3 and 5 we have Ethernet 1x3, which is connected to the downstream host, and both the interfaces are in VLAN 10. So if you see, if I do a show run interface Ethernet 1x3, you can see this particular interface is connected to host 1, it is into VLAN 10. Then I can show you the interface which is connected to spine. In our topology, this one, interface 1x1 on leaf 3. You can see we have simple configuration, right? We have the IP address configured. The OSPF is also configured for the underlay, right? We'll discuss about underlay later, but I wanted to show you that we have set the MTU to 9000, because as you know that because now VXLAN will carry extra overhead. Okay, so we'll be having extra 50 bytes. So normal 1500 bytes are not going to work in this particular scenario, because of that extra bytes that will be added by VXLAN, that we have already discussed in our previous section, right? So that is why I have set it to 9000. So the MTU is set to 9000. Now let's discuss one by one. First, let's discuss about the underlay, how we can configure the underlay. So first of all, I can show you show run section OSPF. Sorry, OSPF. So first of all, we need to enable the feature. Okay. Then we will define. So let me type you one by one so that you will be more familiar. You will, first of all, we will do what we will do. We'll enable the feature. We'll say feature OSPF. Okay. Then we'll say router OSPF. Either you can define a process ID, okay, like 1, 2, 3, something like that, or you can define a name of your choice. For example, in my case, I choose this router OSPF. I choose the name Underlay IGP. Then we will define the router ID. So for leaf 3, I decided 3333, which is the loopback IP of leaf 3. Now OSPF is enabled. We activated the feature, right? We defined OSPF, simple configuration so far, and then we will define OSPF under loopback 0 interface so that we can advertise our loopback IPs into the IGP or the underlay, and on all the interfaces which are connected to upstream device or to spine switches, we need to enable OSPF. So you can see on my configuration, if I do a show running interface loopback 0 or Ethernet 1 by 1, sorry, loopback 0, so you can see that under loopback 0 I defined or I configured OSPF IP with this command IP router OSPF, the process name area 0, and because we are having the point-to-point connectivity, so we are also defining this particular command, or the network type is point-to-point. So under loopback we have configured, and also the interface which is connected to spine switch, we have also configured what? The OSPF, these two commands you can see, right? So this is all that we need to define on our leaf switch for static ingress replication underlay connectivity. So for underlay on leaf 5 also I will show you, we have the same configuration. Show run section OSPF. We enable the feature. These two commands we have already discussed. We need to enable the OSPF process, and the router ID we need to define. And then under the loopback 0 interface, we configured OSPF, and the interface which is connected to spine, we also configured OSPF here. Okay. And also, as you know, we enabled the feature also. So only these things we have configured so far. On spine also same stuff. If I go to the spine, so pipe include, or you can say show features, pipe include OSPF. You can see that OSPF is enabled, right? Then, or you can also check with this show run pipe section OSPF. So the feature is enabled, and we defined the OSPF process, router ID, and then under the loopback 0, you can ignore this command as of now. So we are just talking about the OSPF underlay. We will discuss this when we will discuss about multicast. So this command is not required as of now, okay, for the underlay. So we have just the IP address, we configured the OSPF and the network type. Also for all the interfaces from which are connected to leaf switches, we have on spine, you can see we have Ethernet 1 by 1, 2 and 3, which is connected to leaf 3, 4 and 5 respectively. So show run interface Ethernet 1/123, you can see we have configured these two commands for OSPF on 1 by 2, 1 by 3. This is the only and also you first of all you need to enable the feature that we have already seen, right? So we enabled the feature, and for the underlay connectivity we defined OSPF. So this is the only configuration that is required for underlay connectivity, and obviously as we mentioned that on all the interfaces, core interfaces, we need to define MTU as more than 1550. So normally you will see the maximum or the jumbo MTU configured on the interfaces or on the interfaces of fabric devices, 9216 or 9000, something like that. So now we will see the configuration related to VXLAN. So we need to enable two features. First of all, we will say feature NV overlay. Then we'll say feature VN segment VLAN based. Okay. After we enable these two features, we'll say VLAN 10. We need to define the VN ID against VLAN 10. We'll say VLAN VN segment 10 10 10. Similarly, you can define it for VLAN 20. You can ignore these log messages, not relevant. So you can say VN segment 20 20 20. Now what we need to do, we'll go to the NV interface. Okay, we'll go to NV interface. We'll say no shutdown. We'll say source interface will be loopback 0. Then we'll go to the VNI interface, member VNI and the VNI ID 10 10 10. We need to define source interface, not source interface. We need to define the ingress replication protocol. Ingress replication protocol that we are working today is static, right? Then we need to define the peer IPs, or which means that when we receive any bump traffic for VNI 10 10 10, what are the IP addresses or what are the devices where leaf 3 is going to send the traffic to. Okay, so in our scenario we have two leaf switches, right? So we'll define 444 and 555. This is the only configuration for VXLAN. So if I do show CLI history unformatted, let's say last 20. So we defined these two commands, feature NV overlay, feature VN segment VLAN based. We defined the VLAN and the VNI against those VLANs. Then under the VNI NV interface, we do a no shut. Then we'll define the source interface as loopback 0. Under the VNI configuration, you can configure ingress replication protocol static, and then we defined the remote leaf switches IPs. Okay, so similarly under the NVA interface you can also configure it for VLAN 20 also. You will say member VNI 20 20 20. Ingress replication protocol will be static, and peer IPs will be 444 and 555. This is the only configuration which is required. Okay, so you can check now, show NVE interface. If you run this command, okay, now you can see that our NVE interface is up. Okay, the source interface is loopback 0, and host learning mode, you can see that because we are not running any BGP or anything, we are just relying on the data plane host learning. So you can see that the host learning mode is data plane. If you do a configuration related to some more advanced features like BGP, VPN, then you will say that our host learning mode will be changed, okay, from data plane to control plane. Also, you can check show NVE interface, or I think show NVE VNI ingress replication. Now you can see that we have ingress replication configured, right? VNI ID and the remote tap addresses, VTAP addresses, which are part of the replication list. Because on leaf 4 we are not working, that is why it is showing down. On leaf 5 I already configured a static replication, that is why it is showing up. But for your reference, I will also configure leaf 5 again so that you'll be more familiar with this. So first of all, you'll enable the feature NV overlay, then feature VN segment VLAN based. You will define the VLAN and the VNI against those VLANs, right? VLAN 10, VLAN 20, 20, 20, 20. Then you will go to the interface NVE. You will say no shut. You will say source interface will be loopback 0. You will enter into the member VNI configuration. You will say ingress replication protocol will be static, and you will define the peer IP. For leaf 5, peer IPs will be 333 and 444. Similarly, you can configure it for VLAN 20 or VNI 20. You will say ingress replication protocol will be static, and peer IPs will be 333 and 444. You can check show NVE VNI ingress replication. Now you can see that for NV interface for VNI 10, it can see that we have neighbor 333, right, which is up. Or you can run another command, show NVE peers. Now you can see on leaf 5 we have one NVE peer which is up 333 because we did not do any configuration on leaf 4. That is why it is showing down. And you can see I just wanted to show you one more thing. Show NVE VNI. Yeah, so if you run this command, show NVE VNI, you can see that we have the NV interface for VNI 10, and we are running the unicast static, or it means that we are running the ingress replication, okay, with static mode. Now everything is configured. If I do a ping now from host 1, first of all, if I go to host 1, if I do a show there is nothing in the ARP table of host 1. Similarly, let's check for host 5 also. If I do a show ARP, we can clear the ARP cache and show ARP. Now clear IP ARP. Let's take learning. Let's do one thing. Let's shut its interface. Turn at 0 by 0. I will do a shut and a no shut. Now if I do a show ARP, now there is nothing here. Okay. Now we will try to ping from host 1 to host 5. We do not have any ARP entry. Now obviously they will send the ARP request. You can also maybe do a debug because I'm just using simple router, so I can do a debug IP ARP packets, debug IP or maybe ICMP, debug ICMP packets, or simple debug IP ICMP. So or what we can do, I can capture it. I can show you that the ARP is going through from leaf 3 to leaf 5. So now if I go to host 1 and if I do a ping 10.1.1.5, you can see that we are able to ping from host 1 to host 5. Okay, there are previous captures also. So this is the capture, I think. And you can see here we have an ARP broadcast packet, right? So 10.1.1.3, which is host 1, it is asking about the information related to 10.1.1.5. And now 10.1.1.5 replied that I have this particular IP address, or I have the information about the MAC address of 10.1.1.5, right? See, in my lab, maybe because this is the lab environment, these captures are not working properly, or these devices are not behaving properly. So if you check on leaf switch, if I check the MAC address table, you will see that the leaf switches, they are not learning the MAC address of remote hosts, right? You can see that we do not have any information about the MAC address of host 54555. If you have real devices in your network, or maybe I have some bug in my iOS on this EVNG platform, this 9K image. So in a proper working scenario, you will see the MAC address here, and then you against the port you will see the NV interface and the remote VTAP address, or in our case 555. Okay, so but anyways, though we are not able to see the proper communication between, I mean, how exactly the ARP is going through, what are the different packets, how leaf 3 will save the information about the host 5, how after the ARP is finished, how the traffic will be unicasted from between different leaves. So related to the packet flow, we will discuss about everything in our next lecture. Okay, so I think now static ingress replication is clear. We discuss about why it is required, what are the benefits, what are the drawbacks. Okay, so in our next section we will discuss the packet flow, and then we will discuss how we can overcome the problem of this scalability. Okay, so I hope you enjoy this video, and thanks for watching.